All right, everybody, welcome to the new unit, which is going to be, we're going to do some work on with angles, and we're going to do some work with similar shapes, similar triangles. Anyway, as with the rest of this course, there is no doubt that much of this material you have been introduced to before, obviously in junior high, maybe even before. And of course it gets more complicated, but we just want to make sure that everything's on track here and you know exactly what you're doing. So, one thing you would want to have with you would be a protractor. Now, of course, it's going to be a little bit difficult for me to measure angles and such with a protractor on here. I'm going to do my best to tell you how to do so. I may even just link another video showing you exactly how to do it. But you want to make sure you have a protractor with you while you're doing this unit, because part of this is going to be how to measure angles on your own. Anyway, what we're going to do now is look at some different types of angles, and then we'll move into different relationships and so on. So what we're going to do first is we're going to talk about what is an angle. So an angle essentially is when you have two rays or two parts of a line connected together. This, of course, is going to be, I'll just add some more things here. This is called the vertex of the angle. Okay, and the angle would be the number of degrees in between those two rays, like that. Typically when we write degrees, it's kind of like with temperature, but we might just say this was 32 degrees. That's all you have to put. One other thing I want to talk about is how to name an angle. Quite often what they'll do is I'll say this is A, this is B, and this is C. If you ever have to write an angle, what you would do is you would use the angle symbol, which kind of looks like that. It doesn't really matter how you name the angle as long as this is in the middle. So this would be angle. See, you want this vertex, and it is in between A and C. So A, C, and the vertex point goes in the middle. So that would be angle ABC. I'm not saying this is so appropriate, but you could go angle CBA as long as the B is in the middle. That's your main point here. So that's an angle. An angle is measured in degrees, and that's how you name it. What we use primarily is a protractor to measure an angle. My advice for you is I'm going to give you some practice with this, but what you have to do, I'm going to just draw over this one for a couple minutes. So what you would do, let's say if I took, maybe I'll go in blue, if it comes up here. Let's pretend you had an angle that went from here to here. Now, again, we're going to learn more and more about angles here, and I don't expect you to know too much, but you may look at that and go, oh, well, that's a 50-degree angle. But what a lot of people have trouble with, they say, well, wait a minute. Look, where you just drew right there, that went through, and if I drew it perfectly, it went through 50 and 130. Well, it's like, which one is it? What you do is you always want to put one ray of your angle along the zero line. So what I mean is, look, you want to have one of these angles along the zero line, or one of these rays. And that is your starting point. So you wouldn't start at 180 right there. No, this you put along the zero line, and you measure up in that part of the protractor. So 0, 10, 20, 30, 40, it's a 50-degree angle, okay? If I were to do this to you, let's say I gave you an angle that looks like this. So I'm coming this way, here's my vertex, and I'll jump out like this, okay? So now you're wondering, well, how many degrees is that angle? Again, the problem is on this side, you can see it's going through 20 and about 160. So you're like, well, which one is it? The point is, you always look for which of your rays is along the 0-degree line. And in that case, it's this one right here. So that's your 0, not 180, and you count along. So wherever it's 0 on the top or the bottom right now, it's in the top kind of half circle, and you would count across from there. So 0, 10, whatever, and that should be a 180-degree angle. I will give you practice with that, but just make sure you put one of your rays along the 0 line and use that to count up, okay? So sometimes you'll be on the outer loop, sometimes you'll be on the inner loop. It just depends on where your 0 line is. Okay, so that's not too much of a big deal. I mean, I think you've all done that before, but I will give you practice with that. Okay, let's move along here. Okay, so anyway, this is getting, again, into the protractor. You can see it here. Sorry. This one here, I guess we could talk about it again. It's not really a big deal. But you can see, it's hard to see, but right here, there is a 0 and a 180 right there, just like every other time. Well, this straight line here is right along the bottom. So that's going to, would you count that for your 0 or would you count that for your 180? That would be your 0 line. Whenever you put one of the rays along this bottom, that's your 0 line. And therefore you would simply count up 0, 10, 20, 30, 40, maybe about a 45 degree angle, give or take. Okay, I will give you practice with this. Now into some terminology. These are things that you definitely want to know. We're going to be moving into a unit here soon called trigonometry, which definitely looks at right angles. So a right angle is an angle that measures exactly 90 degrees. Some people will call it a square angle. So if you hear a square angle, that means a 90 degree angle. You probably can look around, you look at various things that are that have perfect 90 degree or right angles. So, oh, and one last thing I want to tell you here. If you ever see, like, okay, here you have a ray and here you have a ray. You have two rays coming together. Sometimes you will see it written, a little figure like this, almost like a little half box. When you see that, that is a symbol for a 90 degree angle. So if you ever, let's say in the future, which I know you will have, you'll have a triangle like this. And so you see you have this line coming intersecting with this line. And what you'll see is I'll put a little shape like that, a little half box. Well, you know by default that that is a 90 degree angle. Okay, we'll move along. Another type of angle is called an acute angle. An acute angle is any angle between 0 and 90 degrees. So if you had, so it doesn't really matter, it could be like this. The whole point is, you know this angle, whatever it is, it's got to be more than 0 and it's got to be less than 90. So it could be like 47 degrees, it doesn't really matter. Okay, so far we know what a right angle is and what an acute angle is. You need to know what these are. So an acute angle is between 0 and 90. Next, we'll move along. An obtuse angle. So this time we've crossed over, and this time it is an angle that is between 90 and 180 degrees. So if I put this in the middle, so here's your right angle. So let's pretend I drew that, that's 90. So an acute would be less than 90, something like 50 degrees. An obtuse now goes, we're kind of rocking this the other way, so it would be like this, where the angle is now greater than 90 but less than 180, so that would be a bigger angle, let's say 130 degrees. Okay, so now we have a right, we have an acute, and we have an obtuse. Okay, and you do need to be able to look or measure angles and state which one they are. Finally, if you have a perfect straight line, that is a straight angle, which is 180 degrees. I do want to point something out here though, and I know this, it sounds simple, but remember, this right here, if you look at this from here to here, is a semicircle, which is 180 degrees. Obviously then, just so everyone knows, and I know you've covered this before, but if you were to go all the way around a circle, so if I start here and go all the way over, so that is my straight. So I've gone from here to here, that's a straight angle. But remember, if you go all the way around a circle, that is 360 degrees. So an entire circle is 360. A straight angle from here to here would be 180 because that is half of a circle. Next, you have reflex angles. Reflex angles are not traditionally used that much. They are between 180 and 360 degrees. One way to look at this is, if you let me just draw one out here. So let's state that, I'll change my pen color. Oh, I have to close that. Let's pretend our angle is from here to here. And I told you that that angle is, I don't know, we'll say 300 degrees. So from here to here is 300 degrees. Well, you can look, what we have here, everybody, is a portion of a circle. And remember, the whole way around a circle is 360 degrees. This may come up, I'm just going to let everyone know, if this is 300, what would it take to complete the circle? Well, 360 minus 300 is 60 degrees. So I guess what I'm trying to show you here is when you have a reflex angle, and this is your reflex angle, which is what I'm here to tell you about. But at the same time, you always can figure out what it takes to complete the rest of the circle. And what I'm trying to say to you is that is an acute angle. So when you have a reflex angle, on the other side of those two rays, you have an acute angle. Anyway, I think that's pretty easy to understand. Just wanted to make sure I pointed that out. If you look at these, you should be able to, using what we have so far, identify the type of angle, okay? So, I mean, I don't really think I need to go over these too much, but, you know, figure 1, you should be able to figure out. That should be an obtuse angle. Figure 2 should be a right angle. Figure 3, sorry, I guess I'm going down here. This is figure 3. This is a reflex angle. Figure 5 would be a straight angle, and figure 5 would be an acute. Please make sure that you can identify those types of angles. I suppose it does say here to estimate each angle in degrees. Well, you certainly could do that because you know the classifications, you know where they have to be. Like for example, figure 2 is an easy one. A right angle has to be 90 degrees. A straight angle has to be 180 degrees. This one's probably the next easiest because you know that's an acute angle and it has to be between 0 and 90. I mean, no one would ever get you, an estimate's an estimate, but I would say it's about 30 degrees probably. Figure 1, that is going to be your obtuse angle, which is greater than 90 but less than 180. Hard to say, we'll just say 140 degrees. And figure 3, that's the the reflex where it's, a good portion of an entire circle. You could say something like 320 degrees because it has to be more than 180, but it has to be less than 360. We'll move on to one more section. Nothing to you. This is all stuff that you've come across before. You have two things here. You have complementary and supplementary angles. Complementary angles are two angles that add up to 90 degrees. So if you look, you have this angle and you have this angle. So I'm even going to give these, so let's say this is A, let's say this is B, let's say this is C, and this is D. If I do this properly, let's name this angle. I know it's 58 degrees, but that would be angle. How would you name it? Remember, the vertex must be in the middle, so that's B, because this angle goes from here out to here. B is the vertex, so it would be angle ABC equals 58 degrees. Let's name this other one. So if I just get rid of all these marks here. Oh, I think I had this as B, this was C, and this was D. So we know the vertex must be the middle letter, so that would be B. This would be angle CBD, and that is 32 degrees. And you know they are complementary because if you add both of those together, you do get a 90-degree angle, which makes total sense because if I just did it like this, you would get that box figure, and that is 90 degrees. This one is straight up and down, this one is straight sideways. They are perpendicular, they measure 90 degrees. So what I can tell you right now, the question that you're going to be faced with, you're going to be given angles essentially like this. You're going to be saying, well, they'll give you something like, well, this is 25 degrees, and they'll say to you, well, how much is this angle right here? The whole purpose is you know that this shape between a vertical and a horizontal line is 90 degrees. You say, well, they're complementary. So all you have to do is you go take the 90, which is the entire shape, take away that 25, and that will tell you how big this missing angle is, which would be 75 degrees. Okay. Finally, we'll move on to the next one here, which is called supplementary angles. Same calculation, same premise, just this time, this is two angles that measure up to 180 degrees, or a straight angle. So again, what you might want to do here, remember, when you have a straight line, what shape can you draw? That is half of a circle or a semicircle. And you know that this half circle is always A half circle is always 180 degrees. So what's going to happen is you're going to get something like this, and they might say to you, well, this is 40 degrees, and they want to know, what is this part right here? Well, all you have to do is realize you have a straight line as your backbone. You can draw a half circle. A half circle is 180 degrees, so you would simply go 180 degrees minus 40 degrees, and that gives you 140 degrees. That means this angle right here is 140 degrees. So, what do we need to know out of this lesson? We need to know what an angle is, how to name an angle, how to measure an angle, the different categories of angles such as right, obtuse, reflex, etc. And finally, you do need to know what complementary and supplementary angles are and how to use that knowledge to help find missing angles. I will give you practice with these things right now.